In the past few years, especially after 2017, blockchain has become one of the most talked about things in the world of cryptocurrency and tech. It's been called the future of currency by industry gurus and the fourth industrial revolution by renowned economists. The good news is that you don't need to be an expert on it in order to understand what it does, why it matters, and how it can impact your business or life in general. If you have some spare time today, we'll show you how exactly what a blockchain is and how it works. In this video, we'll talk about what blockchain is, how it works on a basic level, what problems it solves, and how it can be used. As the name suggests, a blockchain is a system of information. This approach was originally proposed in 1991 by a group of researchers. At first, it was used mainly to timestamp digital documents and to create proofs that could not be backdated or manipulated. It went unused until Satoshi Nakamoto applied it in 2009 to create a digital cryptocurrency called Bitcoin. Blockchain is an open ledger that can be found anywhere, but the ledger has a few traits that make it valuable. Once some data has been uploaded to a blockchain, it is impossible to change it. Which begs the question, how does that work? Let's look more closely at a block. In it, there's some data, the hash of the block and the hash of the previous block. Depending on the type of blockchain, different data will be stored with each block. Bitcoin's blockchain, for example, stores transaction details such as the sender-receiver and the number of coins. Within a block, there's a hash that is paired with a fingerprint. A hash identifies and addresses data blocks, just like a fingerprint does with a person. As soon as a data block is created, its hash is calculated. When you change something inside a block, the hash changes too. That's why hash values are often used to check for changes in blocks. If a block's fingerprint changes, it is no longer the same block. The third element inside each block is the hash of the previous block, and it chains together the blocks. This chain of blocks is what makes a blockchain so secure. With the security system, blockchain transactions are proven to be irreversible. For instance, let's take an example. The blockchain is a distributed digital ledger. Every time you make a transaction, that information is publicly recorded and saved as a block. The block that follows chronologically after it stores the hash of the block before it. The third row points to the second row points to the first row, and the first row is a little different. The first block, called the genesis block, cannot point to other blocks because it is the first one. Now let's say that you tampered with the second block. This would also change the hash of the block. Consequently, that makes block 3 and any subsequent blocks invalid because they no longer store a valid hash of the previous block. Therefore, modifying a single block would render all following blocks invalid. Hashes alone, however, do not sufficiently protect against tampering. Before we go any further with this video, I'll give you some time to subscribe to this channel and give this video a thumbs up if you like it so far. Also, would love to hear your feedback once you have finished watching this. Moving on, computers these days are fast and can calculate hundreds of thousands of hashes per second. This means you could deliberately tweak a block and recalculate all the hashes of other blocks to make your blockchain valid again. To mitigate this problem, blockchains have something called proof of work. It is a means to regulate the creation of new blocks. That being said, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. And this makes it very hard to tamper with blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. Thus, the security of a blockchain relies on its conceptual view of hashing and the proof of work mechanism, as well as one more way of ensuring safety, namely by distribution. Unlike a major authority type chain, a blockchain can be operated through a peer-to-peer network where everybody can participate. For any newcomer to this network, a full copy of the blockchain is stored in their system. As a result, the node can take this to verify that the system is in working order. Now let's talk about blockchain applications. Applications for blockchains can vary based on how you look at them. You can use it as an operating system and then add applications on top of that operating system, or you can simply treat it as a database and go with the traditional SQL operations, just like in the case of any other database. Or we could think of it as a framework to build apps using components distributed throughout its chain. The most basic example of that would be peer-to-peer money transfers. Let's say you have 10 bitcoins, but there are no ATMs nearby where you live, so you have to get rid of them somehow. This time, let's examine what happens when someone sends a new block to the network. When someone sends a new block to the network, everyone on the network gets it. One by one, each node verifies the block, then decides if it hasn't been tampered with. And once it is proven true, each node joins in and stores the block of data. The nodes in this network come to a consensus and unanimously agree about which blocks are valid and which are not. No one in the network can alter blocks in the blockchain. You'll need to rewrite every block on the chain and dominate the P2P network for more than 50% of the system in order to tamper with a blockchain. However, if you do manage to do it, your tempered blockchain will then be accepted by everyone else. But this is really hard to do. Blockchains are continuously improving and changing, with one of the latest developments being the advent of smart contracts. These contracts are simplified programs stored in the blockchain. They can automatically trade cryptocurrencies according to specific parameters. I talked about smart contracts in our previous video, just browse our channel if you're interested in watching it. Also, don't forget to subscribe. Going back, the implementation of blockchain technology piqued many people's interests. More specifically, other people realized that the technology could be used to store medical records, create a digital notary, or even collect taxes. Well, this is the end of the video. I hope you already know what a blockchain is, how it works in its simplest form, and what problems it solves. Hopefully this video has helped you on your crypto learning journey. If you have specific thoughts about topics in the crypto field that we haven't discussed, please share them in the comments section. We always love hearing your comments. See you in the next video.